this video, I'm going to show you how to compute the average value of a function over a given interval. And we use a definite integral to do that. So here are a couple general formulas that we're going to use in this problem. First, so the average value of a given function f of x over a given interval from x going from a to b is it's a definite integral from a to b, so those are the limits, of your function f of x. But once you compute that, then you have to remember to divide by b minus a, the length of the interval, to get the average. Also, a new integration rule that we're going to need for this problem is we know that the integral of e to the x is e to the x, just as the derivative of e to the x is e to the x. Now, if you have a derivative of e to the ax, then we've learned that the way you take the derivative of that is you have e to the ax again, but then you multiply by the derivative of the exponent. The derivative of this, in this case, would just be a, because a is a constant. So your derivative would be a times e to the ax. In other words, you multiply by the coefficient of x. Now here, with integrating, everything works in reverse. Integration is reverse differentiation. So instead of multiplying by the coefficient of x, we're going to divide by the coefficient of x. So that's something you must remember to do whenever you integrate a function like this that's e to a constant times x. You divide by the coefficient of x. This is a very common mistake that students make to forget to do this. It has to become second nature if it's going to come up in a number of problems. So the integral of e to the ax is itself divided by a, divided by the coefficient of x plus c. Okay, so now we're going to use that rule in integrating this function right here. N of x is 290 minus 290 times e to the minus 0.5x. So that coefficient of x is at minus 0.5 there. Now the function refers to production level of a certain item, where x is the number of hours that have elapsed since production began, and n of x refers to how many units have been produced. So when x is equal to 0, e to the 0 is 1, so we get 290 minus 290 equals 0. So of course, when production has started, 0 times elapsed, nothing has been produced. But over time, the production ramps up because this part is getting smaller and smaller, so we're subtracting less and less from 290. So in the end, the maximum production level you can expect is 290 units. So we want to see what is the average production level during those first 2 hours. That's going to be the average value of this function over the interval from 0 to 2. So it's going to be 1 over 2 minus 0, because it's the first 2 hours. So we go from 0 to 2. So it's the integral from 0 to 2 of this function, 290 minus 290 e to the minus 0.5x dx. So here we're applying the formula for average value function on a given interval to get our average production level from hour 0 to hour 2. Okay, so now we evaluate this integral. So we have 1/2 up front, and then I'm going to factor a 290 out of all of this. And then we have integral from 0 to 2, 1 minus e to the minus 0.5x. Okay, 290 divided by 2 is 145. And then the integral of this function, 1 minus e to the minus 0.5x, the integral of 1 is x. And then we have minus, so the integral of this exponential function is itself divided by the coefficient of x. So we divide by minus 0.5, and then we have to substitute in our limits 0 and 2. So if I clean this up, I have 145, and I have x plus, now dividing by 0.5 is the same as multiplying by 2. So I have x plus 2 e to the minus 0.5x with limits 0 and 2. Okay, so now what I'm going to do is substitute these limits 0 and 2 into the function and subtract the results. So first, substituting x equal 2, I get 2 plus 2e to the minus 0.5 times 2. So it's a half times 2, which is 1. So e to the minus 1. And this is a value I'm putting in then parentheses for substituting x equal 2. And then I subtract what we get from substituting x equals 0. So I have 0 plus 2e to the 0, which is 1. So now you're going to have 145 times 2 plus 2e to the minus 1. Okay, so to finish this off, so 2 plus 2e minus 1 minus, then e to the 0 is equal to 1, so I have minus 2. So 2 and the minus 2 are going to cancel out. So I have 145 times 2, which is 290 times e to the minus 1. But I want to get an actual number for that. I want to round this to the nearest whole number. So if I take 290 divided by e, and this calculator has an e button, then rounding to the nearest whole number, I have 107 units. So that is the final answer. That is the average production level during the first 2 hours. So when x equals 0, the production level is 0, but it increases after that point. So after 2 hours, the average over that whole interval of time, 2 hours, is 107